In this video, we will learn about performing an in-order traversal on a tree. Our tree nodes are going to have string values, so the first step will be to include the string header file at the top of the code. Next, we will create a node class. Our node class will have three public attributes: a string named value, a node pointer named left, and a node pointer named right. An in-order traversal is when we visit the left node, then the root, and then the right node. So if we have an example tree with a root of B, a left child of A, and a right child of C, an in-order traversal would visit the nodes in the order A, B, and C. Let's look at how we would code an in-order function. We will create a function with a void return type named Inorder that takes in one parameter, a node pointer named root. Inside of this function, let's check if root equals null. If so, we will return from our inorder function. Inorder is going to call itself, so it is a recursive function. This if statement is the base case that prevents the function from executing indefinitely. Under this if statement, we will make a recursive call to the inorder function and pass in root's left value. Then we will output root's value to the console. After that, we will make another recursive call to the inorder function and pass in the root's right value. That wraps up our inorder function. The next step is to go inside of C++'s main function and write the code we will use to test our inorder function. Let's create a node pointer named root that we set equal to a new node. After that, we will have a node pointer named left child set to a new node. Next, we will create a node pointer named right child, also set to a new node. Then we will assign root a value of B, left child a value of A, and right child a value of C. After that, we will set root's left value to left child, and root's right value to right child. Let's print out our tree to visualize it. First, we will output a few spaces, and then the root's value. Next, we will output a new line, then a /, and then two backslashes, since one is used as an escape character. After that, we will output a new line, the left value of the root, then a few spaces, then the right value of the root. Then we will output two new lines to the console, and finally make a call to the inorder function and pass in root. At the top of the code, let's make sure that we have a using statement importing the standard namespace. I'm also going to add an additional space in the string on line 34, so that the root of our example tree lines up properly in alignment with the other nodes. When we run the code, notice that our tree has B as the root, A as the left child, and C as the right child. Our inorder traversal correctly traversed the nodes in the order A, B, and C. In this video, we will learn how to code a preorder traversal on a tree using C++. Let's create a function with a void return type named preorder that takes in one parameter, a node pointer named root. Inside of this function, we will check if root is null, and if so, we will return from the function. With a preorder traversal, we go to the root, then the left node, and then the right node. So we will output the value of root to the console. Then we will make a recursive call to preorder and pass in root's left value. After that, we will make another recursive call to the preorder function and pass in root's right value. Finally, let's go inside of C++'s main function and call preorder, passing in root. When we run the code, notice that the nodes were traversed in the order B, A, C. In this video, we will learn about postorder tree traversal and how to implement postorder traversal using C++ code. Let's create a function with a void return type named postorder. It will take in one parameter, a node pointer named root. Inside of this function, we will check if root is null. If so, we will return from the function. A postorder traversal visits the left node, then the right node, and then the root. Let's make a recursive call to our postorder function and pass in the root's left value. Then we will make another recursive call to the postorder function and pass in root's right value. After that, we will output the value of root to the console. Inside of C++'s main function, we will make a call to the postorder function and pass in root. When we run the code, notice that the nodes are printed out in the order A, C, B, as expected.